Okay, thank you all for coming. This talk is about migrating the Internet Archive to Kubernetes. It's a love-hate, long adventure story. It's mostly love. It takes a while. We're here to share tips and tricks, explain a little bit of what we went for first, and especially explain our last 6 to 12 months. Yeah. Oh, and my name is Tracey. I've been at the Internet Archive for about 18 years since we started, although I left for 4 years and then came back.
This is a noisy stage. My name is David Van Duzer. I've been in the Internet Archive for about 1.5 years now. I work on the web-wide crawling for the Wayback Machine. So this is a story of how we took on some very daunting, massive technology. The Internet Archive has been around for since the beginning of the web. The platform that we have is in and of itself a daunting pile of technology, which I have become more familiar with more recently. And we're just now tipping our toes into Kubernetes. So what did we find? Any big change is not necessarily going to sit well with all of your colleagues. Figuring out what everyone's pain points are, wrapping all of that up to answer the question, well, what's in it for us? We had a pretty good idea of, we'd been using Docker for a little while. We knew that we have ways of packaging our PHP monolith, but new stuff comes up. It's nice to be able to reuse tools if you can, but new build chains, new things. We all know this, Docker, containerization. But to me, the most interesting thing was that it enforced a constrained model of how to deploy things. So the old saw, constraint breeds creativity. Forced me to learn a new way to develop something that will be ultimately more scalable. So, but rather than get into the weeds of the technical objections and different things that various people might have, we took a little more fundamental look at, well, what does a library actually do? Ultimately, you're just trying to get a bunch of stuff, keep it safe for humanity, for the future, but get it into the hands of people right now. So out of all the things that we do, what was most obviously immediately Kubernetes ready? So we're most famous for the Wayback Machine, which is the thing that shows you any web page from the last 22 plus years. But the Wayback Machine itself operates on this platform that contains books, videos, audio, and whatnot. Here we have the Apple website from 1997, but we also scan books. This one's from 1888. We have book scanners and little applications that have been developed more recently to just crank that workload. Of course, we do virtualization, emulation of old software, and Creative Commons video. This is Sita Sings the Blues, Tracey's favorite Creative Commons film.
It's a great video. It's really creative. We have audio too.
But the point being is that curating all these different types of things has many one-off processes that might be good fits for stateless services that can go into Kubernetes, particularly if we're building anything new. And we do have a lot of one-off projects where we're just, okay, curate this, get it in the archive, and then that goes away. But the payoff from doing this, if that's all we're doing, we're just adding another thing to maintain along with all the other things we maintain. So we wanted to look a little deeper to our storage platform. So this storage platform keeps 50 petabytes or more. It's the 4th generation of the system that we've been using. The important thing to remember is that we're always self-hosting. We're not going to the cloud because then they're the library. That cloud provider's the library, not us. So we want to maintain our independence, but because of the size we've gotten to, we still get the economies of scale, but we've got a much smaller staff. So there is a lot of skepticism to putting 50 petabytes into some brand new distributed storage platform, and ultimately, that's too much. We have a bias towards simplicity. We want to keep, we keep the metadata next to the files. We do index that in a separate database, but database technology may come and go. If we always have that just in a simple block storage device, we don't replicate our failure immediately. Variety of reasons that it's just easier to keep a simpler storage platform and not try to tackle that right away. We've been burnt in the past. We've tried things like ZFS, and no, this is going to be the hardest place to like really dig in. So we found our Goldilocks option with looking at just our front-end application. So we have 4 million daily visitors. That's a lot of, we've got a lot of web servers serving that traffic. Horizontal scaling is what Kubernetes is supposed to do best. But we found that like even that was a little bit too daunting for everyone. So we narrowed into the fact that we're trying to expand to more front-end developers, expand the fold. We have volunteers that want to contribute little bits to that front end. So Tracey?
Yeah, so we have all this content that we sort of mentioned and showed some samples, and we have all these people coming to visit us. So we've got huge amount of content, diversity of bringing it in, diversity of serving it out. And what we wanted to do was explore how could Docker and Kubernetes help us out and modernize basically our own on-premise cluster, hardware all the way down, network, dark fiber, that's us. We're actually in a church in San Francisco if you ever want to come by and see a fun converted church. We have a lot of power coming into this church, a lot of power. So in late 2014, we started using Docker just for audio fingerprinting. So this is kind of like Shazam, so you can match different audio segments or figure out what song something is. We were doing it for something else, but it actually kind of came from the top down, so it was a little controversial. I personally was a little bit frustrated by the way it was introduced to the archive. So I was a little grumpy. Next year, I went to MozFest in London, hosted by Mozilla. I went to this awesome open news Docker talk by the Texas Tribune, and they just stepped us through running Docker on your laptop, kind of showed it to me. I won't touch the lavalier. I sat all cross-armed and thought I was going to hate it, but I loved it, and it just blew my mind, and all I wanted to do was somehow use Docker. I think a lot of us love Docker. So fast forward another year. So when we talked about the audio and video and the different diversity of stuff, you can give us more or less any audio video file or book format, and we'll make a PDF or an MP3 or an MP4. So that took us about a year to switch the processing backend to just use Docker for that processing, and that gave us a lot of safety and less root exploits. And then, if something goes wrong, it just goes away and off it goes. So that was a huge win for us. So almost another year. This is right before Dave and I started sort of pairing up, but we started giving some talks about, we should probably think more. We should think bigger than Docker, think about Kubernetes. It was starting to really take off, and we were really excited. So we gave a few talks, and they went pretty well, but there's some skepticism. I'm more of a developer. David's more of an ops person, but we meet in the middle, and we're getting a little bit of resistance. I think that's pretty common. So fast forward to July of this year, and things really pick up for Kubernetes for us. We're gonna talk about this a bit, but GitLab mentioned in one of their releases that they come with Kubernetes now, and we're like, what does that mean? That can't be right. And we looked into it, and they've got this great thing called AutoDevOps, and it was just mind blow for us. And so we gave this talk called GitLab AutoDevOps Changes Everything. We gave it to all of engineering ops and our executive director. We had a lively discussion at the end. We're open, so if you're interested in even seeing it or want to see some inside baseball, probably the end of that talk at the bottom there might even be interesting. But it went really well because we were able to basically say, we're just going to take our existing GitLab on-premise and we're going to extend that pipeline. So things really started picking up really quickly. A lot of our code runs from a monolithic repo at archive.org, and it has different kind of roles throughout our servers. And we had a homegrown test phase that we needed to move, or wanted to move into AutoDevOps. We moved that in August. And then a month later, we kind of kicked on the rest of the pipeline and started doing what they call review apps. So we'll talk about that a little bit more too, but that's basically a developer or a contractor or a volunteer can have a branch of your tree, and every time they push to that branch, it automatically makes a website. It's fully testable, experienceable. It's great. I guess that would be October, we had a developer who hit me up on the weekend who got all excited and was about to deploy some more web apps. And he was just like, I want to learn Kubernetes. Like, can we just, and he just knocked it out. 2 web apps, start to finish, to manage book scanning related issues and how do you digitize books.
I want to cut in here. Like, I wouldn't describe his attitude as excited about Kubernetes so much as fed up with deploying yet another VM, for deploying yet another application.
Same side of the coin. And then last week alone, we just moved the dweb archive org. So that's a decentralized version of the archive. So the archive is kind of centralized. You're getting that sense since we host our own clouds. This is a way to host materials all around the world using fun things like WebTorrent, IPFS, Gun, WebSockets, all this kind of stuff. And we were able to containerize that and put it into Kubernetes. So the big logjam breakthroughs of, I'm sure a lot of you experience this, like there's just inertia, there's resistance, there's skepticism. But the big thing that I think helped is I get excited easily. People sometimes worry that I'm maybe pushing an agenda. But when David and I kind of found that we're coming at it from different exciting ends and we teamed up, suddenly people were listening. They were like, oh, two relatively and very smart person like agreeing on things and having interesting discussions, and we were foils for each other, and we could help each other. So when one of us wanted to smash our face through a laptop, one of us was like, oh, just do this. So it was really, really helpful. That really accelerated development and just made everything great, and you just feel like you have a mate. So it's kind of like a little love fest, over at the archive. The other thing was this GitLab AutoDevOps. It'd be easy to not emphasize enough how much that helped at the archive, because all we had to do was say, we're already using GitLab. All we're going to do is extend this homegrown pipeline to a full pipeline. We've already got keys. Now we've got audit. We can see so-and-so push this branch, push this into production. It was wonderful.
Real quick, the other big thing that GitLab brought us, we'd been using a Docker Hub or whatever the basic Docker Hub, host your own Docker Hub registry was. And this made me very nervous because there wasn't built-in audit trails, audit authentication. GitLab just took care of all of that. I can now trust that whatever image I was pulling down came from some specific developer's build rather than, I don't know, shared server.
Yeah, David was also great because he looked at our homegrown thing, which is my homegrown thing, and he's like, this isn't secure. What the heck? So he bagged me on that, and he was right. So since we make we do everything ourselves, naturally, you might expect, we're hosting our Kubernetes cluster on premise. So we use kubeadm. It's not too hard to do. I'm not saying you should do it if you haven't, but you can. We made this little repo. It's public called create. And all you need is one VM with SSH access and root. We're aiming for Ubuntu right now, but it would probably work in most Unix environments. And this allows you, we're hoping, and like this other developer did, a coworker can now try it out pretty easily in an afternoon or with some coffee and see what they think. And one thing that we found that was helpful, I'm just going to try to show this now in a semi-live demo, is we built this little simple tool called Collar, and it's just kubectl getting some of the most interesting bits. It was really helpful in us understanding, like, what is Kubernetes doing? What is a replica set? Why is there deployment? It seems like there's all these repetitive pieces.
And because we're old Unix nerds, like, I don't want to try someone's GUI. Like, this was really helpful to just see, oh, quick, I understand the command line, what's going on here.
Yeah, we like the GUI thing, but we showed it to our network guy, and he's like, this is great, I want that. So so it's just in a little watch loop. I can Control-C, it'll repeat, and I'm just going to go ahead and delete this top pod. So this is just a little web app, pretty simple. I've already got it ready to go. I will delete that, and what you can see here is, because it's using watch, it will just highlight all the different regions pretty nicely, and you can see this thing is now terminating. I'll just Control-C. Once it saturates, you can Control-C again. And then you can see it starts coming back. And what that enabled us to do is, as we're bringing up clusters or having issues, you can see, like, hey, why is this thing in a crash loop? You get a much faster feedback because it's polling every second or so. So that was fun, and we included that in the little repo. So, if you're interested, give it a try, mention it to a coworker, or tell us a better alternative,
And normally this is the sort of thing that I would feel like, this is my job, I got to figure out how to set this stuff up. But it really was daunting to try to install your first cluster. And Tracey's enthusiasm was like, I don't care, I'm going to just plow through this until I get it working, really helped me too.
Yeah. And then later, when we needed persistent volumes, his enthusiasm in plowing through, figuring out the technology, Gluster, then Ceph and Rook, was unbelievably helpful. So again, you want to avoid bad blood, as Tay would say. you want to make sure that you don't push your devs people, your ops people too much. You want to make sure that they're feeling included, and you want to identify common pain points and what helps both. And honestly, some of the things that we thought we were going to do first, certainly the thing I was gunning for the most, didn't wind up helping people the most, so we actually switched gears. And if you bring people together and you come with common goals, then just like Marvel and DC, you could meet on the moon and you could go and defeat Darkseid, at least for an annual.
I guess downtime is the metaphor here. Darkseid.
Yeah. The capital D Darkseid. Okay, anyway. So one other thing we thought would be interesting would be to show sort of before and after. We're running both of these right now. But we had a relatively nice way to have quick development at the archive. So my Unix name is Tracey. And we have home directories on our Bastion server. And those are exported and shared throughout our entire cluster over NFS as home. And what it allows you to do is you can edit directly on that Bastion. I sort of started out that way using Emacs and then eventually moved to VS Code on my laptop. So you can do both or either. And kick in on these SFTP kind of things that'll sync over a save. So you get immediate feedback. So if you want to change a title of something or other or a typo, it's very, very quick. And we use Nginx virtual host to pull off this minor magic. It's not really that exciting, but if you come to archive.org and you're on a node that's been load balanced to, it's going to go to /petabox, www, something or other. That's where your route will go. If you come to www-your name, you'll go to home, your name, petabox tree, and then you can get instant feedback. That's kind of cute and it works out nicely, but once you start having multiple branches or you have some complexity or trying to bring in other developers or volunteers, it starts getting a little heavy-handed and hacky. It wasn't really, it didn't really feel like it was starting to feel a little outgrown. Also, there's the issue of NFS home mounted on servers and just giving out key access and SSH keys. So what Kubernetes, the AutoDevOps, from GitLab with the Kubernetes tie-in, you just punch in your Kubernetes credentials and it ties right in. What that will do is that allows you to have developers make these branches, not have SSH keys, not log in anywhere, none of that. The head of our websites actually said in a meeting once when he was asked, what do you think of Kubernetes at this point? And he said it was a game changer, which I was just like, yes. And that was the thing that I didn't even expect, but he said, we've got developers in India and some random people that we're not really super tied or close to, or in Russia. So they can now push code and they can see it happen instantly without needing us to come in 12 hours later, approve it, push it to some server or anything like that. You get instant feedback and it sticks. So as you keep pushing, those changes continue to go to that website.
And this might all seem like old hat to the new crowd of who's grown up with CI/CD systems, but
this is great for us.
Yeah.
This is new for us. And we also made in that same repo something called branch sync edit, which is kind of like a simple find your pod, sync the code to it, so you can do a quick edit if you don't want to do the entire pipeline. And I'll hand the mic to David in a second, but if you haven't seen pipelines before, or maybe GitLab AutoDevOps pipelines, this is fairly standard. It's a little different. We put test in front of build. We'll go over that. And expanded the test, but this is exactly what you can expect to see. You'll go through a build step, a test step, a review step where it actually pushes it out to that review server, and then if you either remove or merge the branch or you want to just manually stop the review, then that asset will go away. And by the way, they pull this off with a DNS wildcard trick, which makes it really nice so they can come up with any name they want.
Yeah, so that really helped out our front-end developers, gave them like a bunch of obvious benefits. But I also wanted to find out, wanted to test this theory that this could make other kinds of application development a lot easier. So I took our existing crawling. I'll just quickly review like what crawling does. It's pretty simple. You start with a list of websites called seeds. You go out and you download a bunch of websites. You extract links from that, and then what do you have now? You have another list of websites that you can keep crawling. So you're just going to keep doing this over and over again. And so back in 2009, Internet Archive developed its own Java open source crawler called Heritrix. But it's designed for, it runs on the JVM. It really is designed for big machine. And once the web grew to billions and trillions of URLs now, one machine wasn't good enough. It's very good at pipelining the stages and really churning fast through a bunch of different fetches and persists and processes like that. But we needed to get inside that loop in order to get multiple crawlers working together once we wanted to expand it and distribute the application. So the initial design of this was pretty straightforward. It's you get in that loop, you aggregate all of the URLs, you have some kind of store that says, have I seen this URL in this crawl cycle, yes or no, because we don't want 1,000 copies, we don't want to fetch 1,000 copies of the Google logo every time we crawl. And so it just sits in the middle of this crawl HQ tool. So I took that on as, well, let's figure out how we can deploy that in Kubernetes. So it's real easy to replace 38,000 lines of in-house code with a bunch of other people's code, but Kafka and FoundationDB really fit the bill for the volume of work that we were working with. So the discovered URLs just go into a Kafka topic. Then there's a little worker that has to say, well, have we seen this yet? And it uses FoundationDB for that store. And I could have run this like a bunch of processes on a few different VMs. We pretty much know how to deploy applications that old way. But once Tracey had set up all of this fundamental work for me, I was able to write this program and then scale it by just changing one single variable, the replicas variable, in the GitLab AutoDevOps. And so one process would process a few hundred URLs per second, but the crawlers were going faster than that, so turn the replicas number up to 20 and then 60, and it would just keep scaling, and I didn't have to think about it. And it was like beautiful, great way to develop something new. Of course, not everything we have is quite like that.
Yeah, we'll see if this works. So, welcome to the monolith of code. And it's actually, we have petabytes. The code is gigabytes, but we just thought that would be fun to show that's actually one of our real storage racks. So, we could break up things. We could kind of come up with a schedule and spend a lot of time. But ultimately, because I like to smash my head in things, I just thought, well, what if we can actually jack a huge monolith of code in and make it work somehow? So just a little background. We have a 4.8 gigabyte tree, 20 years worth of commits. We came from CVS, SVN, up to Git. So it's a lot of data, a lot of old files and logs. We're making currently 6 to 9 gig Docker images for the various roles and things we're using. One big thing that, just as a side note, that we found is if we put test in front of build, which sounds a little weird, our developers would get feedback within seconds or maybe a minute or two as opposed to waiting for the entire build. We're able to pull that off because we start with a baseline Docker image with a shallow clone. And that helps with being able to jump forward, and we're going to talk about that. Because what we found is out of the can, the initial way that GitLab AutoDevOps, which might change in the future, is doing things is it's doing a git clone per phase, and that was just a non-starter for us. We were waiting 4 minutes per phase, times 10 or 20, sometimes in parallel, but it was just way too much. So to give you just a little bit of more background, our code base is the petabox tree, and we make something we call a petabase image. We don't have to go through all this, but it's basically a baseline Docker image with third-party packaging, and then this shallow clone. So a shallow clone with Git means no history, no prior files, just kind of your current snapshot. And then we can actually use this little piece that can be built once every week or 2 or 3 or 4 even, and just do a quick fast forward and go right into CI testing. Some of the other images we were making, again, we won't have to go into all this detail, but so when I was talking about the MP3s and MP4s and making PDFs before, that's this left side here. So that's, we'll make the workbase, which has additional packaging and things like that. That's third party. And then we'll make worker on top of it. But all of these endpoints, like for the website Kubernetes candidate, for testing on your laptop, or for miscellaneous nodes, it's all using the same trick. Start with petabase, fast forward in. Yeah, and so when you get shallow clone, for us at least, we found we could drop our tree size by 1/3. So that was significant enough to really speed up our times. And anything that's going to go ahead and use it is going to ask for a specific commit and fast forward right to that. And we'll go over that in just a second. And then to speed up our build phase, we found using the prior build phase, which was helpfully right in the GitLab Docker registry, just pull from that bootstrap, because we're mostly just doing code changes, and go from there. That really sped things up too. All right, so you might be on your phone. That's great. It's getting towards the end of the conference. If you are, you might want to hold up your phone and take a picture of the next slide, because how do you fast forward these Git shallow clones? It's
Surprisingly difficult.
surprisingly difficult. I was working on this for weeks. I was not crying exactly, but I was getting tomatoes hurled at me. The devs were really upset. Okay, so what this does, in a nutshell, is it takes that Git shallow repo. It does a checkout detach. That just kind of keeps it out of the way in case there's anything locally modified or don't keep you out of trouble. And the magic here really is this git fetch depth 1, using the origin of the branch, from the origin, the branch or the commit you want. So what that does is that keeps your repo shallow, because if you just did a git fetch, it would basically fill out the entire repo, and now you've got to pay 4 minutes of penalty. And then you can just check out immediately to it. Now, it's worth pointing out, this sort of fell off screen, but there's a GitLab on-prem config setting that will allow you to get to any commit, because I think there's a concept of, you might want to, you might decide a commit had some sensitive information, you want to remove it, but it's still kind of there. So there's things like that. There's how much time you can get back if you want to jump 6 months forward or something like that. So if you set this one little setting, you can see the PDF if you want to see the full thing. That's the other magic. And this is really because we have this guy, Mark Sullivan, so a huge shout out to him. He's a huge Git pro. If you need a Git pro, maybe talk to us, because he's amazing. Some other top tips sort of wrapping up here are, if you want to try like a Kubernetes with 1 or 2 nodes, you can have a single node and taint the master and say, I want to run pods, just keep it simple. You can use local storage, and that's a huge time savings, because you don't have to figure out how to use something else if you want to just run it on your laptop or whether. It's a nice little win. GitLab AutoDevOps comes in with something called Postgres. It comes in with an empty Postgres database, trying to be very helpful, but that makes persistent volume claims that you don't need if you're not going to use it, and by default you probably won't use it, so recommend turning that off in this little CI/CD variable. It's right in the GUI. And then the GitLab API, just a shout out to it. Like everything you see on GitLab's website, you can pretty much get to through the API. So we could do pretty advanced things like say, where's the most recent master branch? Has it succeeded through test or failed? And our devs can instantly find that on a page and know, is it okay to push out? Periodically, you might want to remove some of your old replica sets on the Kubernetes side we found when you host it. I'm sure the cloud providers do some of this for you. And we found that you want to probably trim your registry periodically, because it just sort of builds up. One very last thing, this is really in the weeds, but for DWeb, we needed to expose all sorts of fun and interesting ports. We had a hard time with any of the ingresses, and it was baffling. I spent almost a week on that, and David jumped in and tried to help, did help. And basically, you can't do it. At least I couldn't find any way to do it. So you just make a separate load balancer, and it's just 2 lines of code. It figures out what the service is, figures out what the exports are, and it just handles all those ports for you. So that was a really nice thing, and that allowed the DWeb to go out after some delays. A little tip of the hand, we're going to try to hopefully, knock on wood, move the archive.org production website to Kubernetes, because right now we have a static list of VMs with HA proxy, and we'd like to be smarter and move to something like Kubernetes with elastic scaling.
Thanks for coming.
Thanks for coming.